Assalamu alaikum and hello everyone. Today we are going to talk about something that sounds boring at first, but trust me, by the end of this lesson, you will actually like it. So, our today's topic is about errors and uncertainties in measurement. You know, when you are performing a lab experiment and your teacher says, measure this carefully, but no matter how careful you are, it still feels like the answer is slightly off. Don't worry, you're not careless. That's actually how science works. So let's understand it in a very simple, real world way about errors and about uncertainties. So, part first of this lecture, of today's lecture, basically revolves around errors. What are errors? First of all, in science, the word error doesn't mean mistake. It simply means the difference between the actual value and the value you measured. For example, let's say the length of a pencil is really 15.0 centimeter, but when you measure it, you write 14.7 centimeter. That 0.3 difference, that difference is the error. Not because you did something wrong, but because no measurement is ever 100% perfect. Now moving on to the second part of today's lecture, which is about uncertainty. Someone might ask you, what is uncertainty? Uncertainty means how sure you are about your measurement. For example, you measured the pencil as 14.7 centimeter. We are talking about the length of it, okay? But your scale's smallest marking is 0.1 centimeter. Remember, the 0.1 centimeter actually refers to the least count. You should be remembering your 9th and 10th class topics, okay? So your final result will be written as length is equal to 14.7 centimeter plus minus 0.1 centimeter. That plus minus 0.1 centimeter tells everyone that you're not 100% sure. Your answer could be slightly more or slightly less. And that's not bad. It's actually a scientific way of being honest. Now moving on to the subtopic of these two topics. For the first one in this regard is the types of errors. There are actually three types that we are going to discuss one by one in today's lecture. The first one is the systematic error. This is when your instrument or method has a built-in problem. For example, your ruler starts from 0.3 centimeter instead of 0. Even if you measure perfectly, your result will always be wrong in the same way. That's called systematic error. It affects every measurement equally, be it your friend's measurement or another group's measurement. Yeah, all of you will have something wrong about your measurement. Then the second one is the random error. Random errors happen because of tiny unpredictable things. Maybe your hand shook, maybe you looked at the scale from a weird angle, or maybe somebody moved your chair while you were performing the experiment or moved that table. Remember? One time you measure 5.2 centimeter, next time 5.0 centimeter, and then 5.1 centimeter. These differences are random errors. You can reduce them by repeating the experiment and taking the average. That we have done in 9th grade and 10th grade, and we will do onwards as well in the intermediate classes. Okay. So the third one and the last one in today's lecture is the human error. This one's funny, because we all have done it. You forgot to zero the weighing machine, you misread the thermometer, or you wrote 1.9 instead of 19. These are human errors because simple mistakes, not scientific ones. And guess what? Scientists make them too. Yes, don't be shocked about it. Moving on to our very not that important with regard to today's lecture, but one of the important topics in physics, which is the least count and accuracy. Remember that every measuring instrument has a least count, the smallest value it can measure. For example, a normal ruler has a least count of 0.1 centimeter. That means you can't be more accurate than plus minus 0.1 centimeter when using it. So if your answer is 13.4 centimeter plus minus 0.1 centimeter, that's the best you can do with that ruler, and that's okay. A question arises here: if we have these errors, how to reduce them? How do we reduce these errors? So there is a way, and here are 4 simple ways to do that. Use instruments with better least count. Repeat the experiment, repeat the measurement, and take the average. Read instruments carefully at eye level, no guessing. And record values neatly. Don't rush it. You don't need to rush. That is it. No rocket science, just a bit of focus and awareness. So, the next time someone says your result is wrong, you can proudly say, no, it's not wrong, it just has some uncertainty. And that is the language of real science. If this helped you, don't forget to revise it once before your test or next lab, because this topic always shows up somewhere. This is it from my side. Bye.